Hello everyone, welcome to another recitation video. In this video we're going to be covering example 7.17 from the notes. In this example we're going to calculate the required sample size necessary to detect a specific effect size when testing the difference of two proportions. We will be analyzing 4 different scenarios where we look at different values for the power and a different value of P2. So to start off, we're going to calculate several variables in our data step. The first is z underscore alpha. This is the critical value of 1 minus alpha over 2. The next variable is going to be beta. By definition, this is 1 minus the power. We then calculate the critical value of 1 minus beta. In this case, we call it variable z underscore beta. We then calculate the proportion of failure. We call it Q1 and Q2, which are the values 1 minus P1 and 1 minus P2 respectively. The next variable is P bar, which is the average of P1 and P2, which is just the sum of P1 and P2 over 2. We define our next variable Q bar to be 1 minus P bar. The effect size is just the absolute value of the difference between P1 and P2. And here we'll denote it with ES. With all those previous variables defined, we can finally calculate the sample size. So as you can see here, the code is a bit cumbersome, so I'm going to bring up the general form of the formula up on screen here. We're using the same formula in the code, we're just substituting the variables present in the formula with the variables we declared earlier. We then create our final variable, which is simply the ceiling of the variable we had just created, because obviously integers are required for the sample size. Finally, we can use cards or data lines to bring in our data, and as you can see, the only 2 variables that are changing are the power and the values of P2. Finally, we specify proc print, and then specify the variables we'd like to include in the output. Then when we highlight and run, we will see the dataset featuring the newly calculated sample sizes on the right. From the table, we can make some observations. We can see that with a larger power, the larger sample size is necessary. Also, we notice that with an increase of P2, in this case, the sample size gets larger. However, that trend doesn't always hold true, because if the effect size increases, so too does the denominator in the calculation. So that concludes example 7.17. Thank you very much for watching, and I'll see you in the next video.